Okay guys, last section of this chapter, last quadrilateral we're going to look at for a while are kites, a special kind of quadrilateral. Okay? First of all, kites are not parallelograms. We do not have two sets of opposite parallel lines. Okay? Kites don't follow that. We do have two sets of congruent sides, but they're not opposite each other. Okay? So let's take a look at just that first example here to get a picture and to get a definition down. Okay, in your first picture, here's what I want you to mark as congruent. In a kite, we're going to have two sides congruent that are right by each other and another two congruent that are right by each other. Okay? Notice this is very different from a parallelogram. In a parallelogram, these two sides would have been congruent and these two sides, okay? So our first kind of compare, contrast, okay? So the definition of a kite, it is a quadrilateral with two pairs of consecutive congruent sides, okay? All right, and we've contrasted that a little bit with what a parallelogram is, and write something up so you are understanding that contrast, okay? Might even be helpful. Draw another picture off to the right of a parallelogram and contrast the two. All right, let's go to the next one. Let's see what the diagonals look like, and let's see what the angles look like. Okay, draw another kite here. Draw a little bigger one this time. Okay, so we have a kite. Okay, once again, we have two sides that are congruent, that are consecutive. Okay, and let's draw in some diagonals. Let's go from here to here. Like that. All right. Well, it turns out that we have a little bit of the property of a rhombus here. It turns out that these diagonals are going to be perpendicular. They're going to meet at a 90-degree angle. Okay? So it has a little bit of the properties of a rhombus, but it's not a parallelogram, so it can't be a rhombus. Okay? So, what else happens? Well, there is only one set of angles that are going to be bisected. Okay? We'll take a look at, there's only going to be one set of segments of lines that are bisected. Okay? It turns out that this side here and this side here will be bisected. Okay? These two sides will not be. And if you just look at this example, you can see it's kind of obvious that that won't happen. Okay? So, we can't say, like in a parallelogram, that the diagonals bisect each other. They don't. But one of the diagonals will bisect another diagonal. Okay? All right. Let's go down to our third one, and let's do a little look at the angles. Okay? Let's take that off this time. I'll draw another one. You have it there already. All right. Okay. So again, we have two consecutive sides congruent, like that. All right. Well, it turns out that for the angles, that only one set of opposite angles will be congruent. Okay? And it will always be this side right here and here. In other words, look at the angles that are between two non-congruent sides. Okay? This side and this side are not congruent. So this angle and the angle across from it are what will be congruent. Okay? The top angle, the bottom angle are not congruent. But something else does happen. If we draw in this diagonal again, even though this one and this one are not congruent, it turns out it does bisect this angle it works as an angle bisector, and it works as an angle bisector for this angle. Okay? A lot of things going on kites, okay? And it's kind of this mismatch of properties we looked at for all of the other shapes. So this is another reason I want you to do some flashcards, be able to go through and say what isn't true on each of these shapes, okay? A lot of information. Take some time to get some notes down. Pause the video if you need to. Watch it again, okay? These are the big things on kites. And again, it has a little bit of what's going on, but not everything. All right. Once you're done and ready to keep going, let's look at the examples on the back page. The nice thing will be is, I don't think we'll do any coordinate geometry on kites. Yay! I hope everyone is cheering at about this point. Along with the fact that I'm not making you do proofs on this, ought to be a good day. All right. So we have a kite, and just looks a little different this time. Wow, that's a bad kite. Let's go there. Okay, and we have a bisector, not a bisector, a diagonal. A diagonal. A, B, C, D, intersects at T. Okay, that's what we got. We ask if the angle BAD is 38. Okay, let me get a different color here so this shows up. All right, if this angle here is 38 degrees altogether, okay, and BCD is 50, okay, here, there, there, okay, we want to find the measure of ADC, all right? Well, let's think here. Well, this angle here is not going to be congruent to either this side or this side. It's only congruent. These are the two congruent angles, okay? The angles between the non-congruent sides. Well, we're not given an angle measurement up here, so that's not going to help us. So we've got to think just a little more about what do we know about all quadrilaterals. What does the sum of the angles add up to? 360. So, if we took 360 and subtracted off these two angles, we would at least know what these angles have to add up to. So let's do that real quick. That'll be 360 minus 38 plus 50 is 88. Okay. 5, 2, so we got 2, 7, 272 degrees. So, this angle and this angle add up to 272. Since we know they're congruent, we'll just take 272 divided by 2 to find our answer. So, 2 goes in one time, goes in 3, 6, 136 degrees. So our measure for ADC is 136 degrees. Okay? One example of something you might see. Let's look at the next question. It uses the same diagram. If BT is 5, okay, and TC is 8, okay, 8. Find CD. All right, well, we're going to have to pull a couple of different ideas in here. We said, first of all, that this line right here, between these two sides, would be bisected. Okay? So, BT and DT are the same measurement. Okay? We can't necessarily say that about CT and TA. We want to find CD. But what else do we know about the diagonals? They are 90-degree angles. What do we have now? We have a right triangle. If we have a right triangle, what can we use to find the hypotenuse? Pythagorean theorem. So, I'm going to erase this little bit right here. So, A squared plus B squared equals C squared. We'll call A squared 8. So it's 8 squared plus, we'll call this B, 5 squared equals C squared. Let's see, 8 squared is 64. 5 squared is 25. That'll equal C squared. Then we get 64 plus 25, which is 89, equals C squared. And we could just leave the square root symbol there and say that that distance is the square root of 89. If you punch it into your calculator, round it to the nearest tenth, that's okay too. All right, so that is the distance from C, D. Okay? Again, we kind of pulled a lot of different ideas to be able to find this one segment. And maybe a help on some of these is when you get a picture like this, start filling in the things that you know. Okay? Even if the question isn't asking for it, start filling in what you know because that might help you answer the final question. Okay? All right.